All right, so we now have this, the mass presumably, well, actually it will cancel out, so the mass will be irrelevant. R I would typically give, in a typical problem I would give R, I would give G. Mass I'd probably throw in there just for the fun of it, or not. What we don't know is V or Y. Those are our two unknowns in a typical problem. So I need to solve for it. Now, one method is you isolate Y, plug into the other equation, and get rid of it. I'm going to show a slightly different technique in the fact that I'm just going to divide. I'm going to divide the left sides, I'm going to divide the right sides. So on the left-hand side, my y's will cancel out. And what is sine theta over cosine theta? I heard it mumbled. Tangent of theta. And on the right-hand side, well, mass will cancel out, and I'm left with v squared over gr. So if I want to figure out what that ideal speed is so that I can take this frictionless ramp and not fall off, well, I just solve for v, which is the square root of gr tan theta. So let's give a radius of curvature here of, let's just say 100 meters. And let's put this on Earth 1. So we end up with the square root of 9.8 meters per second squared times 100 meters times the tangent of 25 degrees. And we end up with
Does it need to be in radians?
no, this is 25 degrees.
21.3771.
21.3771
Yes.
units.
Meters per second squared? Per second?
Yeah, meters per second. It's a speed. So that's how fast you would need to go in order to take this curve. If you went faster than that, what would the car do?
Go out of the curve.
Which way? Up the ramp or down the ramp? Okay. And if we're going slower, Dominic?
Is R equal to 100?
Yes.
Okay.
Yeah, I threw that in right here.
Yeah.
Technically, the way you would find that is you have a curve. If it's a constant curve with the same radius of curvature, you take any point and then draw a line tangent to the path. And then you take another point, draw a line perpendicular to the tangent, and they would meet at the center. So, ideally, this would be the same. All right, questions here before I make it more complicated? Okay, so we now have found that ideal speed. What I'm going to do now is I'm going to have the car taking this curve at 30 meters a second. So now I'm saying that the speed is 30 meters per second. Obviously, unless I throw friction into it, that's going to hit the curve and it's going to move up to the top of the curve. So we need to throw in friction, and I'm going to say the coefficient of static friction, we're going to make, well, actually, let's figure out what that needs to be. What is the minimum coefficient of static friction so it will not slide to the top? Another variation of this is I give you the coefficient of static friction, and you figure out what is the maximum speed that car can go so it won't slide before it starts to slide. Why am I not doing kinetic friction? Why static?
Because we're trying to solve where it is so it stays in this position.
Okay. And if it's sliding, then we're dealing with kinetic. So what changes here? I mean, the problem is still 25 degrees. That's the same. Acceleration is still towards the center of the circle. That's the same. Coordinate system, that's fine. Does the force diagram change?
We have to add friction.
Yeah. Which way is friction going to act?
So it's not frictionless anymore?
Not frictionless anymore. We're trying to figure out if it's going 30 meters per second, what is the minimum coefficient of friction so that it will not slide?
Would the car be down and to the right?
Yeah. Because the car without friction, that car is going to move to the top. Friction says, no, I don't want that. So friction will be acting this way. It is static friction because the wheels are, we don't want the wheels to be skidding at all. So we need to break friction up also. Now, since we've already broken normal force up, breaking up the friction is simple. They are perpendicular, friction and normal force are perpendicular to each other. Therefore, the trig functions change. They flip. So before I had y sine theta, well, I still have y sine theta towards the middle. Friction is going to be to the right and down. So friction, I'm going to have a component to the right and a component downwards. That is not better. Well, horizontally, normal force was sine. Now friction, cosine. And since vertically, we had y cosine, this will be friction sine.
It's supposed to be straight, right?
The f cosine?
Yeah.
Yeah, that's it's supposed to be to the right. That anymore. This will start to change. Now the equations of motion will look very similar, but we have these two extra terms to get thrown in there. So let's go ahead and set those up. What are our I hat and j hat equations? What is the I hat equation?
So which one did J have?
J hat is vertical, I hat is to the right.
The J hat, right? I think that's y cosine theta minus weight. And is it minus again for the friction sine theta? Equals mass times 0.
Spot on. So now the I hat equation. Dominic?
Y sine theta plus f cosine theta is equal to MA.
So our centripetal force here is the horizontal component of the normal force and plus the horizontal component of the friction. All right, what's next? What comes after equations of motion? Dominic?
It's one of the two S's.
That is correct. The last S is solved.
I would.
So for what do we have an independent formula for our substitution phase? All right, and so we'll have a formula for that. Yep. So we have y sine theta plus f cosine theta equals m v squared over r, and y cosine theta minus mg. Actually, I'm going to go ahead and bring mg over to the other side. Minus f sine theta equals mg. Actually, we have one other one though. We have one other independent formula.
Friction.
Yeah. Now, because we're dealing with static friction, officially the formula for static friction, it's less than or equal to mu s times y. But we're looking at an extreme here. We're looking for the minimum value of mu s so that it will not slide. If we're at an extreme, just go ahead and set it fs equal to the maximum value of fs. So this f here, mu s y and minus mu s y. All right, got this nice little equation right here. We're trying to solve for mu sub s. I don't know mu sub s. I don't know y. I know m. I know g. I know r. I know v. So my unknowns are the coefficient of static friction and the normal force. How do you solve?
Let's go for the bottom one. Is it y cosine minus mu sub sy, and then is it plus or minus sign, or is it connected with sine theta?
It's y cosine theta minus mu sub sy sine theta. That's all. That's three things multiplied together there.
Oh, okay, the friction is being substituted for, or the F in the friction is getting substituted for the use of sy.
Yes.
Okay.
Any other questions before someone reveals how to solve this?
We can, both of the right sides are, we know, right?
Right. Good. Do you think you can just stick numbers in? Well, I don't know. I didn't actually give a mass. Do you want a mass? If I don't tell you the mass, it means one of two things. What are those two things?
It's weightless. Yeah.
If it were weightless, then there'd be no normal force. Alright. if I don't give you a mass, it means one of two things. It either means you don't need it, because it would cancel out, or I made a mistake. In this case, you don't need it, it would cancel out. So in that case, you can make, if you want to plug numbers in at this point, just make up a number that's not zero. So you can make it a 1 kilogram car. It will just as well as making it a 1,000 kilogram car. Anyway, so how do we solve this? Solving from use of S.
Simplify,
Okay. How?
cancel out stuff, divide the top by the bottom, like thing you did a second ago or a minute ago, and start canceling the stuff out.
What if you,
All right, let's be careful about that.
did you
Okay.
get rid of the static friction?
Well, we wouldn't be able to because the static friction is connected to the cosine and sine. Well, I guess that's like a way you get rid of the.
Wait, no, you wouldn't.
If I have 4x plus 5y equals 13, and, let's see, that's, so, and 2x minus 3y equals 10. If I divide the sides, what can I cancel out over here?
We still cancel out the y, but you can't cancel mu, like the use of sy cosine is one big thing, you can't cancel that out. You can't divide that by the mu sub y sine.
Okay, but we can get rid of the y's this way. Because I can factor a y out of this, factor a y out of this, then divide, the y's go away. Is it the simplest? No, that's one way your mind's working. So this would be y times sine theta plus u sub s cosine theta equals mv squared over r, and then over here I have y cosine, y times cosine theta minus mu s sine theta. That's sine theta over mg. If I divide now, my y's cancel out, and I'm left with a single unknown. It's even more so an algebra problem.
Can you cancel the m's?
Yes,
You said it's mg over 1.
so we get v squared over rg. If mu sub s, and this is a quick check here, if mu sub s is 0, in other words, frictionless, this goes away, and I'm left with sine over cosine, which is tangent, is equal to v squared over rg, which is what I had the first time we went through this. So, feel like we've done something right. All right, so how do you solve this? We have sine theta plus mu s cosine theta over cosine theta minus mu s sine theta equals v squared over rg or gr.
He times it by cosine theta minus u of s sine theta.
Go to multiply everything by this denominator.
Yeah.
Okay. So if we do that, we end up with sine of theta plus mu s cosine of theta equals v squared over gr times cosine of theta minus mu s sine of theta.
And he times it by 0.
Oh, okay, so in essence, we're cross multiplying,
Or
if you want to. Okay, now what?
Is this how you would do it?
probably not.
Actually, yeah.
It is? Okay.
The only other way I might do it is not multiply both sides by GR, but just keep that as a number. But the next step is the next step regardless of which way you do it. Trying to get mu isolated.
Vector. Wait, no.
Wrong way.
Divide both sides by b squared. That's a star.
For
Okay, but distribute.
distribute.
FOIL officially is if you have two binomials and I've got a single term and then a binomial. So I have GR sine theta plus GR mu S cosine theta equals V squared cosine theta minus mu S V squared sine theta. So you distribute this inside. Now what?
Put mu's on one side.
Okay, since this is negative here, and I know it changes signs when you move over, I'm gonna move the mu's over to the left side and the non-mu's to the other. So I have GR mu S cosine theta plus mu S V squared sine theta equals V squared cosine theta minus GR sine theta. So now all the mu's are on one side, now what? What's the advantage of getting all the both mu terms on one side?
Vector.
Yeah. Factor it out. They're both to the first power, so I don't have to do a quadratic, it's a linear thing. So I have mu S times GR cosine theta plus V squared sine theta equals V squared cosine theta minus GR sine theta.